Welcome to this math channel. Today we're going to discuss about arithmetic sequence. Before we continue, let us have a recall of important concepts. A sequence is a function defined on the set of consecutive positive integers or on a subset of consecutive positive integers. In other words, a sequence is a function whose domain is the set of positive integers. Each value in a sequence is called a term. The first term is usually denoted by a subscript 1 or a sub 1. The second term is a sub 2. The nth term is denoted by a sub n. The nth term is also called the general term of the sequence. The sequence with terms 4, 11, 18, 25 is called a finite sequence because it has a last term, while the sequence containing the terms of positive consecutive odd integers is called an infinite sequence because the last term is not indicated. Now let us proceed to the definition of an arithmetic sequence. An arithmetic sequence is a sequence in which the difference between successive terms is a constant. This constant is called the common difference. The formula for the nth term or the general term of an arithmetic sequence is developed by using the fact that any term after the first term is the sum of the preceding term and the common difference. Let a sub 1 be the first term. To get a sub 2, we add the constant or the common difference to a sub 1. So we have a sub 2 equal to a sub 1 plus d. To get a sub 3 or the third term, we add the common difference to the previous term, that's a sub 2. But a sub 2 is equal to a sub 1 plus d. Hence, we have a sub 1 plus d plus d. Therefore, a sub 3 in terms of a sub 1 is a sub 1 plus 2d. Now, let us get the fourth term, that is a sub 4. So, a sub 4 is equal to a sub 3, the previous term, plus d. But a sub 3 in terms of a sub 1 is a sub 1 plus 2d. Therefore, in terms of a sub 1, we can have a sub 1 plus 2d plus d. And a sub 4 is equal to a sub 1 plus 3d. Let us continue with the fifth term. That will be a sub 5 equal to a sub 4 plus d. Again, a sub 4 is equal to a sub 1 plus 3d. Therefore, we have a sub 4, that is a sub 1 plus 3d plus d. Then a sub 5 is equal to a sub 1 plus 4d. Notice that there is a pattern to get the nth term of the arithmetic sequence. In terms of a sub 1, that will be a sub 1 plus 1 less than the number of terms times d. So if we're going to get the nth term, we'll just have a sub n equal to a sub 1 plus n minus 1 times d. In here, a sub n is the nth term of the arithmetic sequence. A sub 1 is the first term. N is the number of terms. And d is the common difference. This time, let us have some examples. Example number 1. The first term of an arithmetic sequence is 5, and the common difference is 7. Find the 11th term. In this problem, we're looking for the 11th term, that is a sub 11. And we are given a sub 1, that is the first term, equal to 5, and the common difference is 7. From the formula a sub n equal to a sub 1 plus n minus 1 times d, we can substitute a sub 1 equals 5 and d equals 7 to get a sub 11, or the 11th term. So we have a sub 11 equals 5 plus, in here n is equal to 11, that is a sub n, and we're looking for a sub 11, therefore n, the number of terms, is 11, minus 1 times 7. So we have 5 plus 10 times 7. 10 times 7 is 70. Therefore, the 11th term is equal to 75. Example number 2. The nth term of an arithmetic sequence is 4.50. If the first term is 1.00 and the common difference is 0.25, find the value of n. In here, we're looking for the value of n, and we are given a sub n is equal to 4.50. A sub 1, the first term, is 1.00. The common difference is equal to 0.25. Again, let us use the formula. A sub n is a sub 1 plus n minus 1 times d. And substitute the values. We have 4.50 for a sub n. A sub 1 is 1.00. We're looking for this value n, and d is 0.25. Using the concept of order of operations, we can solve for the value of n. Subtracting 1 from both sides, we'll get 3.50 is equal to n minus 1 times 0.25. This time, we divide both sides by 0.25. We have 3.5 or 3.50 divided by 0.25, that is 14, equal to n minus 1. And lastly, adding 1 to both sides of this resulting equation, we have 15 is equal to n, or n is equal to 50. Let us continue with example number 3. In an arithmetic sequence, a sub 3 is equal to 11, and a sub 6 is equal to 20. Find a sub 1 and d. In this problem, we are given two terms of an arithmetic sequence, and we're looking for the values of a sub 1, the first term, and the common difference. Since we're given a sub 3 is equal to 11, let us use the formula a sub n is equal to a sub 1 plus n minus 1 times d, and get the equation for a sub 3 and a sub 6 in terms of a sub 1 and d. For a sub 3, we have a sub 3 is equal to a sub 1 plus 3 minus 1 times d. Hence, substituting a sub 3 equals 11, we have 11 is equal to a sub 1 plus 2d. Let us have this as our equation 1. Also, for a sub 6, we have a sub 1 Since n is 6, we have 6 minus 1 times d. And substituting a sub 6 equals 20, we have 20 is equal to a sub 1 plus 5d. Let us have this as our equation 2. Notice that in equation 1 and equation 2, we have two equations in two variables, a sub 1 and d. So to get the values of a sub 1 and d, we will use methods of solving systems of linear equation. In here, we're going to use elimination by addition or subtraction. So to eliminate a sub 1, we subtract equation 2 minus equation 1. Equation 2 is 20 equal to a sub 1 plus 5d. And equation 1 is 11 equals a sub 1 plus 2d. Subtracting term-wise, we'll have 9 is equal to a sub 1 minus a sub 1 is 0. 5d minus 2d, that is 3d. Now, dividing both sides of this resulting equation, we get d is equal to 3. Now we have the value for d. To get the value of a sub 1, we substitute d equals 3 to either equation 1 or equation 2. Let us use equation 1. That's 11 equals a sub 1 plus 2d, so that is 2 times 3. 2 times 3 is equal to 6, and subtracting 6 from both sides of this resulting equation, we have a sub 1 is equal to 5. This time, let us continue the discussion with arithmetic means. Arithmetic means are the terms between any two given terms of an arithmetic sequence. In the arithmetic sequence, negative 4, 3, 10, 17, 24, and so on, the terms 3, 10, and 17 are the arithmetic means between negative 4 and 24. If a and b are two real numbers, then the arithmetic mean between a and b is given by a plus b over 2. Hence, if we're getting the arithmetic mean between two numbers, we just get the average of these two numbers. Let us have some more examples. Example number 4. Insert 3 arithmetic means between negative 8 and 36. In this problem, we are asked to insert 3 arithmetic means between negative 8 and 36. So we have negative 8. Then we'll have the 3 numbers. And then 36. Hence, if this is an arithmetic sequence, a sub 1 is negative 8. And a sub 5 is 36. Getting the common difference of this arithmetic sequence, we'll use a sub 5 equals 36, and the equation will be a sub 5, that's 36, equal to a sub 1, that's negative 8, plus n minus 1 times d. And since n is equal to 5, then we'll have 5 minus 1. So we have 36 is equal to negative 8 plus 4d. Adding 8 to both sides of this resulting equation, we have 44 is equal to 4d. And then we divide both sides by 4, we get d is equal to 11. So the three arithmetic means may be obtained by adding 11 to the previous terms in this arithmetic sequence. If a sub 1 is negative 8, then a sub 2 will be negative 8 plus 11, that is equal to 3. A sub 3 will be 3 plus 11, that is equal to 14. A sub 4 is equal to 14 plus 11, that is 25. To check our answers, let us get a sub 5, that must be 36. That is 25 plus 11, 36. Hence, our answers are correct, and the three arithmetic means between negative 8 and 36 are 3, 14, and 25. This time, let us have some practice exercises. In the practice exercises, you will be given 15 seconds to answer. You may opt to pause the video and play it again when you are ready to check whether your answer is correct. Let us have exercises number 1. The fourth term of an arithmetic sequence is 8, and the seventh term is 20. Find the first term and the common difference. You have 15 seconds. Go. Time is up. Let us check the answer. The fourth term is 8. So we have a sub 4 equal to 8. And the seventh term is 20. So we have a sub 7 equals 20. We're looking for a sub 1 and the common difference. The equation for a sub 4, that will be 8 is equal to a sub 1 plus 3d. 3 is obtained from 4 minus 1, since n is equal to 4. And the equation for a sub 7, we have 20 equal to a sub 1 plus 60. This is our equation 2. 6 is obtained from 7 minus 1. We're going to solve these two equations simultaneously to get the values of a sub 1 and d. Let us subtract equation 2 minus equation 1. So we have 20 is equal to a sub 1 plus 6d, and equation 1 is a equal to a sub 1 plus 3d. Subtracting term-wise, we'll get 12 is equal to 3d. Dividing both sides of this resulting equation, we get d is equal to 4. Now we substitute d is equal to 4 to either equation 1 or 2 to get the value of a sub 1. Let us choose equation 1. So we have 8 is equal to a sub 1 plus 3 times 4. 8 is equal to a sub 1 plus 12 from 3 times 4. Subtracting 12 from both sides of this resulting equation, we have a sub 1 is equal to negative 4. So d is equal to 4 and a sub 1 is negative 4. Next, let us have practice exercises number 2. Find the arithmetic mean between 16 and 26. You have 15 seconds. Go. Thumbs up. Let us check the answer. We have here two numbers, 16 and 26. Let us recall that the arithmetic mean between two numbers or two real numbers a and b is equal to a plus b over 2. So we just need to get the average between 16 and 26. Therefore, the arithmetic mean between 16 and 26 is 16 plus 26, that is 42, divided by 2, 21. If 21 is the arithmetic mean between 16 and 26, 16, 21, and 26 must form an arithmetic sequence. And for an arithmetic sequence mean, we must have a common difference. Let us try and subtract. 21 minus 16 is 5. 26 minus 21 is 5. Therefore, we have a common difference, that is 5. Our answer is correct. Practice exercise number 3. Insert two arithmetic means between 50 and 62. 15 seconds. Go. Thumbs up. Let us check the answer. We are to insert two arithmetic means between 50 and 62. So we have 50 as a sub 1. Then we have two arithmetic means. 62 will be a sub 4. 50 is a sub 1. 62 is a sub 4. Hence, we're going to use the equation for 62 as a sub 4. And a sub 4 is equal to a sub 1 plus 4 minus 1, because n is equal to 4 times d. Substituting the values, we have 62 is equal to 50, that is our a sub 1. 4 minus 1 is 3, and we're looking for the common difference d. Subtracting 50 from both sides of this equation, we get 12 is equal to 3d. And d is equal to 4, obtained by dividing both sides of the equation. Since d is equal to 4, we have a sub 2 equal to 50 plus 4, that will be 54. And a sub 3 will be 54 plus 4, that is 58. To check our answer, a sub 4 must be 62, and 58 plus 4 is equal to 62. The answer is correct, and the two arithmetic means between 50 and 62 are 54 and 58. That will be all. Thank you for watching. Please subscribe for more math lessons.